fine print note to 110.14 only refers to the proper tightening of the terminations in the panel board or other equipment. This section of the National Electrical Code merely states that the tightening of connections shall be done according to the product instructions for bolted or screwed connections. Here are some other excerpts from the National Electrical Code that may help in determining the importance of using torque screwdrivers. 690.44d states that terminals shall be tightened according to the manufacturer's recommended torque values. 300.12a states that only approved connectors and fittings are to be used. 300.12b states that connections and splices made in accordance with the instructions furnished by the manufacturer of the device shall be considered to be approved. 250.12 states that connections shall be made up tight and secured against loosening. It can be summed up as follows. Firstly, use the product instructions for tightening bolted or screwed connections. Secondly, use approved connectors and fittings. Thirdly, follow the manufacturer's instructions for making connections and splices. And fourthly, all connections shall be made up tight and secured against loosening. Based on these statements, I would conclude that although there is no specific code requirement that states one must use a torque screwdriver, by using the manufacturer's instructions for the product, and by ensuring that all connections are made up tight and secured against loosening, you would be in compliance with the National Electrical Code. Also, see Article 110.3b for other general requirements for making electrical connections. 110.3b discusses other requirements and states that electrical connections shall be made up in a manner to secure a permanent and reliable connection, and shall be made in accordance with the requirements of the National Electrical Code. The National Electrical Code, or NEC, doesn't explicitly mandate the use of torque screwdrivers for all terminations in panel boards or other equipment. However, several sections emphasize the importance of proper tightening and adherence to manufacturer's instructions, which often implies the necessity of using appropriate tools, including torque screwdrivers, to achieve the specified torque values. The core principle throughout the NEC is to ensure safe and reliable electrical connections. This is achieved through a combination of approved materials, proper installation techniques, and adherence to manufacturer's specifications. Let's delve deeper into the specific sections of the NEC that bear relevance to this topic. 110.14 focuses on electrical connections and terminations. While the fine print note of BN is not an enforceable rule, it does provide guidance on the importance of proper tightening. It essentially points out that connections should be tightened according to the manufacturer's specifications to prevent overheating and ensure a reliable connection. This is where the understanding of torque becomes crucial. Over-tightening can damage the conductor or the termination, while under-tightening can lead to loose connections, arcing, and potential fire hazards. The manufacturer's instructions will typically specify a torque value, usually expressed in inch-pounds or newton-meters, that represents the optimal tightness for that particular connection. 690.44d, which specifically addresses photovoltaic systems, provides a more direct requirement. It states explicitly that terminals shall be tightened according to the manufacturer's recommended torque values. This highlights the recognition within the NEC that specific applications demand precise tightening, and manufacturer's specifications are paramount. While this section applies to photovoltaic systems, the underlying principle applies to all electrical connections: the need for proper torque to ensure a reliable and safe connection. 300.12, covering raceways and cable assemblies, also plays a role. Although not directly related to torque, it emphasizes the use of approved connectors and fittings, and that connections and splices made in accordance with the manufacturer's instructions are considered approved. This reinforces the idea that following the manufacturer's guidelines is a key element of compliance. When manufacturers specify torque values, they are essentially providing instructions for creating an approved connection. 250.12, dealing with connection of grounding and bonding equipment, requires that connections shall be made up tight and secured against loosening. This might seem like a general statement, but it underscores the necessity of ensuring that connections remain secure over time. Proper torque is a significant factor in preventing loosening due to vibration, thermal cycling, or other environmental factors. 110.3b, which covers examination, identification, installation, and use of equipment, states that electrical equipment shall be installed and used in accordance with any instructions included in the listing or labeling. This section broadens the scope beyond just connections, emphasizing the importance of following all manufacturers' instructions for the entire installation process. In the context of electrical connections, the manufacturer's instructions often include torque specifications. In summary, while the NEC might not always explicitly mandate the use of a torque screwdriver for every termination, it strongly implies its necessity through various sections that emphasize adherence to manufacturer's instructions, proper tightening, and the creation of secure and reliable connection. The use of a torque screwdriver is often the only way to ensure that connections are tightened to the specified torque value, leading to compliance with the NEC and promoting electrical safety. To provide a more practical understanding, let's consider a typical scenario involving a panel board installation. A qualified electrician will first review the panel board's labeling and documentation to identify the specified torque values for the various terminals within the panel. These values may differ depending on the size and type of conductor, the type of termination, and the manufacturer's design. Using a calibrated torque screwdriver, the electrician will then carefully tighten each connection to the specified torque value. This ensures that the connection is neither too loose nor too tight, both of which can lead to problems. The calibration of the torque screwdriver is also crucial. Regular calibration ensures that the tool is accurately measuring the applied torque. A torque screwdriver that is out of calibration can lead to over-tightening or under-tightening, negating the benefits of using the tool in the first place. It is also important to understand that different types of terminations may require different tightening techniques. For example, some terminals may require a specific tightening sequence to ensure even pressure distribution. The manufacturer's instructions will typically provide guidance on these techniques. In addition to torque screwdrivers, other specialized tools may be required for certain types of electrical connections. For example, crimping tools are used to create secure connections between conductors and terminals, and wire strippers are used to remove insulation without damaging the conductor. Using the correct tools for the job is essential for ensuring a safe and reliable electrical installation. Let's consider a few scenarios where proper torque is particularly critical. Firstly, high vibration environments. In locations where equipment is subject to vibration such as near motors or heavy machinery, proper torque is essential to prevent connections from loosening over time. Secondly, thermal cycling. Connections that are subject to thermal cycling, such as those in outdoor equipment, can expand and contract with temperature changes. Proper torque helps to maintain a secure connection despite these changes. Thirdly, high current circuits. In circuits that carry high currents, even a slightly loose connection can generate excessive heat, leading to arcing and potential fire hazards. Proper torque ensures a low resistance connection, minimizing heat generation. Furthermore, it's worth noting that many manufacturers of electrical equipment require the use of torque screwdrivers as a condition of their warranty. If a connection fails due to improper tightening, the warranty may be voided if it can be shown that a torque screwdriver was not used. Therefore, using torque screwdrivers is not only a matter of complying with the NEC but also of protecting the investment in electrical equipment. To further illustrate the importance of proper torque, let's consider the consequences of over-tightening and under-tightening. Firstly, over-tightening. Over-tightening a connection can damage the conductor, the terminal, or both. It can also strip the threads of the screw or bolt, making the connection even weaker. Secondly, under-tightening. Under-tightening a connection can lead to a loose connection, which can cause arcing, overheating, and potential fire hazards. It can also lead to premature failure of the equipment. Therefore, achieving the correct torque is crucial for ensuring a safe and reliable electrical connection. In conclusion, while the NEC may not explicitly mandate the use of torque screwdrivers in every situation, the underlying principles of the code and the manufacturer's instructions strongly imply their necessity. Using torque screwdrivers is essential for ensuring proper tightening, creating secure and reliable connections, and complying with the NEC and protecting your investment in electrical equipment. The electrical work should only be performed by qualified individuals who are trained in proper installation techniques and who understand the importance of using the correct tools and following the manufacturer's instructions. This ensures the safety of the installation and the people who will be using it. The NEC is updated every 3 years to reflect changes in technology and industry best practices. It is important for electricians and other electrical professionals to stay up to date on the latest code requirements to ensure that their work is safe and compliant. Furthermore, local jurisdictions may have additional requirements beyond those specified in the NEC. It is important to check with the local authorities to determine any additional requirements that may apply. Proper electrical connections are not just about tightening screws, they are about ensuring the safety and reliability of the entire electrical system. By following the NEC, adhering to manufacturer's instructions, and using the correct tools, qualified individuals can create electrical installations that are safe, reliable, and compliant. Remember that electrical work can be dangerous. Always take the necessary precautions to protect yourself and others from electrical shock and other hazards. If you are not qualified to perform electrical work, hire a licensed electrician. Finally, always remember to disconnect power before working on any electrical equipment. This is the most important safety precaution you can take.